Next, we have to take problems based on the electric flux and Gauss law. The problem is a charge Q is enclosed by a Gaussian spherical surface of radius r. If radius is doubled, then outward electric flux will be. We know that electric flux phi E is equal to integral E dot ds. This is the dot product of electric field and the elementary surface area. And Gauss's law states that this electric flux enclosed by a Gaussian surface is 1 by epsilon naught times of the charge enclosed by the Gaussian surface. This implies that integral E dot ds equal to 1 by epsilon naught times of the charge enclosed. Here it is important to note that this electric flux depends only on charge enclosed by Gaussian surface. If charge is outside the Gaussian surface, that will not influence the flux linked with the Gaussian surface. So as per question, the charge Q is at the center of the sphere which represents the Gaussian surface with radius r. Now if radius is doubled, then charge enclosed remains same, and because charge remains same, hence electric flux will remain same. So option C is the correct option. Next question is, a charge Q is placed at the center of a cube of side A. The electric flux emerging from the cube is, suppose we have a cube and one of the charge Q is placed at the center of this cube. So this cube basically acts as the Gaussian surface, and the Gaussian surface encloses the charge small q. Therefore, the flux linked with the Gaussian surface, that is the cubical surface, will be 1 by epsilon naught times of the charge enclosed, and charge enclosed is q, so the flux will be q by epsilon naught. This is the answer. Next question is, a charged particle q is placed at the center O of the cube of length L, A, B, C, D, E, F, G, H. So this is the charge which is at the center of the cube. Another same charge Q is placed at a distance L from the point O. So another charge is Q which is outside this cube. Then electric flux through ABCD. If we mark this ABCD, this is the surface through which we have to find the flux. If we consider this cube as the Gaussian surface which encloses the charge placed at the center, then flux is 1 by epsilon naught times of the charge enclosed, that is q. And we know that for a Gaussian surface, the charge inside the Gaussian surface will cause the flux, outside will be ignored. So there is no role of this outside charge, and this flux q by epsilon naught times is linked with this cubical surface, and this cube has 6 identical and symmetrical surfaces or faces. Therefore, the flux linked with any of the surface, here we are considering the surface ABCD, this is the one of the face, and all faces are identical, and there are the 6 identical faces. So flux linked with one face will be 1/6 of the total electric flux, and it will be equal to 1/6 of q by epsilon naught times. This is the answer. Question is, a charge q is located at the center of the cube. The electric flux through any of the face, as earlier done, that flux linked with a cubical Gaussian surface will be 1 by epsilon naught times of the charge enclosed, which is the q, and there are the 6 faces or surfaces of the cube, and which are identical and symmetrical with respect to the origin of the center, this implies that flux linked with any of the phase will be 1/6 of the total flux, and it will be 1/6 of the Q by epsilon naught times. This is the answer. Next question is, what is the flux through a cube of side A if the point charge Q is at one of its corner? We have already done that. If charge is placed at the center of the cube, then the flux linked with the cube is Q by epsilon naught times. And through any of the phase, it is 1/6 of the Q by epsilon naught times. We will do this problem alternatively, where there are the 8 equivalent cubes touching the corner which is having the charge Q. The figure shows that the cube which has the side A has a charge at the corner which is Q. Now, with this contact, we have shown here 4 unit cells which are in backward direction. Similarly, similar 4 unit cells which will touch this corner from the front side. That means this corner is shared by the 8 equivalent unit cells of the side A. Therefore, this charge Q is at center of cube of side 2A. If we see the side of the cube, now it is 2A. Therefore, the flux linked with this cube of the side 2A will be equal to 1/epsilon naught times of the charge enclosed, this is Q. And this flux is shared by 8 cubes of side small a. This implies that phi E for the cube of side A will be equal to, because this flux is equally shared by the 8 cubes, so it will be 1/8 of the flux of the larger cube of side 2A. So it will be Q by 8 epsilon naught. This is the answer. In the alternative questions, a charge Q is situated at the corner of a cube. Electric flux through all of the 6 faces, that means it refers the cube of side A of the cube is. So this is the same, 8 by Q by 8 epsilon naught. Next question is, a charge Q is placed at a distance A by 2 above the center of the square surface of edge A as shown in the figure. The electric flux through the square surface is. So this is the similar question which we have done for the cube. For cube, we have said that if charge Q is placed at the center of cube, then the flux will be through the cube will be 1/epsilon naught times of the charge enclosed, that is Q. And through a face, because there are the 6 faces and equivalent, so flux with the single phase will be 1/6 of the total flux, that is Q by 6 epsilon naught. If we compare this case with already done case, we see that this is the squares which have the side A, and the charge is placed at a point P at a distance A by 2. So if we complete this cube, we will have the situation similar, that charge Q is placed at the center of the cube and we have to find the flux through the square surface. It means through one of the face. So we can easily write that electric flux through the face of this square surface, that will be equal to 1/6 of the total flux with the cube, that is Q by epsilon naught times. So answer is Q by 6 epsilon naught. Hence answer option B is the correct option. Question is, if the electric flux entering and leaving a closed surface respectively are phi 1 and phi 2, the electric charge inside the surface will be. From Gauss law, we know that flux through a Gaussian surface will be equal to charge enclosed divided by the epsilon naught. This is the Gauss law. Here, the net flux is the difference of the entering and the leaving flux. So the difference is phi2 minus phi1, and it will be equal to 1 by epsilon naught times of the charge enclosed. This implies that charge enclosed by the Gaussian surface will be epsilon naught times of the phi2 minus phi1. Hence, option A is the correct option. Next question is, find the electric flux associated with the surface where the electric field lines are along the same plane as of the surface. We know that flux is defined as integral E dot ds, and this is equal to integral E ds cos theta, where theta is the angle between electric field and surface. The field direction of the surface is perpendicular to the plane of the surface. Hence, in both cases, we can say that theta equal to 90 degree. And because theta is 90 degrees, so cos 90 will be 0. Therefore, flux will be 0 in the both cases. Also, we can visualize it as that field lines are parallel to the plane, so okay, they will never cross the surface, so net flux will be 0. Hence, for A, the net flux will be 0. For figure B also, net flux will be 0. Question is, a Gaussian surface is shown in the figure represented by this dotted line. The electric field on the surface will be. Here we have to note that, note 1, the flux is due to charges enclosed by Gaussian surface. If charge lies outside the Gaussian surface, that will not be responsible for the flux. And electric field is due to all charges, either inside the Gaussian surface or outside. So in this question, a Gaussian surface in the figure shown by dotted line, the electric field on the surface will be due to Q1 and Q2 only, due to Q2 only, 0 only, due to also. Option D is the correct option. If we were asked that the electric flux on the surface is due to, then in that case we will say that minus Q1 and minus Q2. Next question is, 4 closed surfaces and the corresponding charge distributions are shown. Here for the surface S1, there is a total charge 2Q inside the Gaussian surface. In Gaussian surface S2, total enclosed charge is Q plus Q plus Q minus Q, that means it is also 2Q, and there is no charge outside. For Gaussian surface S3, total inside charge is 2Q and outside charge is 5Q. In Gaussian surface S4, total inside charge is 8Q minus 2Q minus 4Q, that means it is also 2Q, and outside charge is 3Q. Let the respective electric flux through the surfaces are phi1, phi2, phi3 and phi4. We know that electric flux is due to only the charge enclosed by the Gaussian surface. So we will ignore the charge outside the Gaussian surface, and all 4 cases charge inside the Gaussian surfaces is 2Q. Therefore, the flux will be 1 by epsilon naught times of the charge enclosed, and that will be equal to 1 by epsilon naught times of the 2Q, because each surface has the 2Q charge inside them. Therefore, we can say that phi1 equal to phi2 equal to phi3 equal to phi4. So option C is the correct